This is a short video about how to use a web application that allows you to examine three-dimensional seismic velocity structures of the crust uh, in, in, in both map view and also looking at cross sections. And it's a web application, so uh, this application runs in the browser, and you can use it either on desktops or cell phones or any kind of a uh, mobile device that allows you to use a browser. The website is located at this particular HTTP address, so it's crust3d.ddns.net. So there's no www in front of it. It's just http dot slash and then crust3d.ddns.net, and that's the web address. So if you actually go to your browser, and if you go to your this is a Firefox browser. If you go to the browser and just enter this particular address to the into the browser and then press enter, and you're gonna be presented with this particular web page. And at the top, it's showing you basically this particular web app has two components. One is a map component, which basically shows you the map view of a three-dimensional shear wave velocity model at different depths. And then you have a cross-section view, which basically presents the shear wave velocity at a particular cross-section from 1 to 2. And these 2 points, the starting and ending points, can be sort of adjusted on the map view. So once you get to this particular web page, you can look at this particular velocity model. For now, the velocity model only covers the region that contains the California, most of the Oregon, Nevada, most of Nevada, um, and some part of the Arizona. So if you would like to, this model actually goes from 0 km depth to about 95 kilometer depth. So if you would like to, so red color, the color bar basically shows you the shear wave velocity value. So red color means lower velocity, and blue color means higher, or cold colors means higher shear wave velocity. So you can sort of see that at shallow depths, this is at 1 km depth. So basically, this shows you the depth, right? This shows you the depth of the map view, right? And you can sort of see at shallow depths, lower shear wave velocities are basically correlated with major sedimentary basins in this particular region, right? And you have some kind of artifacts close to the boundary of this box, but these kind of artifacts can be corrected later on when we sort of move to a box that's sort of covers this kind of region, right? And then we'll get rid of those artifacts. And there are also artifacts, some slight artifacts um, at some of the model boundaries, because this big model was composed by stitching together some smaller models, and you can sort of see some artifacts located at the boundaries of those smaller models. Right? And you can adjust the depth of the model. If you want to look at the deeper, you just click on this button. Then it's going to take you to 2 km depth. Again, some artifacts, but this part can be easily corrected, right? So 3 km, 4 km. So if you click on deeper, then it's going to take you to a larger depth. And both the map view and also the color bar are going to adapt to that particular depth. So basically, you can sort of keep going deeper until to about 95 kilometer depth. And if you want to go shallower, just click on shallower. Then it's going to take you to a shallower depth. And the color bar was constructed by so the color range goes from like red to blue, and the white is actually the mean. White color actually corresponds to the average velocity for this particular depth. So white actually corresponds to taking the average of every grid points. Every grid point. Take the average of the shear wave velocity at every grid point at this particular layer. And then the extreme red actually corresponding to 30% smaller than that average. And extreme blue is sort of 30% higher than that average. And if the value is sort of, if the actual velocity value is actually beyond that 30% range, then the color is going to saturate. So values smaller than 30% of the average is going to have exactly the same color as the shear wave velocity value that is exactly 30% smaller than the average. The same is true for blue. So if a shear wave velocity value is larger than 30% of the average, then it's going to have exactly the same color as the value that has that's exactly 30% larger than the average, basically. So that's, you can also zoom by using the zoom button on your mouse, right? The screw wheel of your mouse allows you to zoom in. So once you actually zoom in, you're gonna see lots of the geological provinces, lots of the city names, those geological markers, right? This is a Death Valley National Park. It basically tells you where you're actually looking at. So, and you can also zoom by clicking on this button, right? Zoom in or zoom out by clicking these two buttons. So, and then you can sort of, let's look at the cross section part. Let's look at the cross section part. So on the map view, you can sort of see two dots, a green dot and a red dot. Green dot has number 1 on it, and then red dot has number 2 in it. So basically, these two markers are going to decide where you're going to draw the cross section. So both the green dot and the red dot can be moved around. So if you point your mouse to one of the points and then drag it, just hold down the left key, hold down the left mouse button, and then just drag it. You can move the points around. And as you actually move the points, the numbers showing these boxes actually changes. So these two boxes are for the longitude and latitude of the green dot, the point 1 basically. And then these two boxes are for the longitude and latitude of the red dot, the red dot is point 2 basically. And after you have finished adjusting these 2 points to the location where you want to extract the cross section, you can just click on the create cross section button. And after a while, it's going to extract the cross section, the shear wave velocity cross section along this particular profile, and it's gonna be displayed at this location. And the one thing that you have to pay attention to is that it says that point 1 on the left and point 2 on the right. So point 1, that's the green dot. That's the green dot actually corresponds to the left boundary of the cross section. And then the red dot is going to correspond to the right boundary of the cross section. So this is point 1, and then this is point 2. Right. It doesn't really matter geographically where the 2 points are. If you actually put point 1 here and then point 2 here, then if you do the create a cross section, point 1 is still located on the left, and then point 2 is still located on the right. So if you actually put your point 1 and point 2 this particular way, then the cross section is basically just for the cross section. The cross section actually starts from point 1. The left boundary actually is corresponding to point 1, and then moves to point 2. So it's actually moving this way. So starting at point 1 and then moving towards point 2 and stop at point 2. So starting at point 1 and then move towards point 2 and then stops at point 2. Basically, that's sort of the convention of the cross section. And then you can not just drag these two dots. You can also click. You can also click on the map. So if you actually click on the map, so now I have point 1 and point 2 that's sort of located this way. If I click on the map, the previous point 2 is going to become the new point 1, and the location that I'm clicking is going to become the new point 2. So if I left click here, so the previous point 2, the red dot, actually now becomes a green dot, point 1. And then the location that I have clicked becomes a new point 2. And then if you click on create a cross section, it's going to create a cross section goes from point 1 to point 2. So if I reload this page by clicking on the reload button of my browser, I'm gonna go back to the default startup page with point 1 and point 2 that's kind of located in the middle of the box. Right? It's not gonna store the cross section that you just picked. Right? So if you would like to, every time you open this page, you would like to see the cross section that you generated last time you logged in, you have to use this sign in. So if you click on this sign in, it gives you a account management page, account management box basically. So it allows you to create an account, and it also allows you to sign in. So if you want to create an account, you can just click on the create account button, and then it's gonna ask you for an email address and a password. And then once you enter the email address and password, you can just click create account, and then you're gonna be automatically signed in. I'm gonna close it. Sign in. So I have an account already, so I'm gonna sign in. Password, and then click on sign in. So now I have signed in, and this box basically displays my email address. But you can sort of see both the cross section and the map view are still stopping at the default startup page, right? But if I reload my browser, I have reloaded my browser by clicking on the reloading button, and then it's going to take me to the last time I looked at this model. It's going to take me to the last cross section that I was extracting. Right, that's point 1 and point 2. The last time I looked at this particular model, and here's the cross section along that particular profile. And if I sort of move it to a different region, for example, right, and generate a new cross section, for example, right. I've generated a new cross section along this profile, right? And then if I log out, sign out, and if I reload my web page, it's gonna go back to the default web page, default startup page, right? But next time I sign in, Now I'm signed in using the same account. And then if I do another reload, it's gonna take me to that cross section that I last time I extracted last time before I log out, before I sign out. So if you would like to sort of keep track of the web pages you've been looking at, you can try to create an account. You can try to create an account and then uh, sign in to this web application every time you're using it. But it's not mandatory. You don't really have to sort of create an account and sign. You can just use uh, the default account to examine the model in any way you want, right? But it's not going to keep track of the application. It's not going to keep track of the progress you've made or the last cross section you were looking at. Um, so this model is the fourth iteration of a full 3D tomography work in this particular box. Future iterations inside of this box are going to be posted at the same website. And if I have new models for the entire United States, for example, or for other regions of the United States, they are also going to be posted at this website. And hopefully we can cover the entire United States or lower 48 states in about 2 years, right? Hopefully. But for now, that's a good start. And if you have any questions or if you have any suggestions or comments, please feel free to email to me at either at my web address, which is at my email address, pchen@uwyo.edu, or you can email it to my Gmail address, pseudopocchen@gmail.com, or pochengeophysics@gmail.com. Right. Either of those addresses should be fine. If you discover any kind of problems of the model, please also email it to me, and I can fix those problems in future versions of the velocity model. And if you have any suggestions about the web application, if you want to see more capabilities of the web application, you can also email it to me, and I can make improvements to make it easier to use. Or okay, that's this particular web application.